The broadcast is now starting. All attendees are in listen-only mode.
Hey everybody, Luke here again with another Inventor 101 webinar. This week we are going to wrap up part modeling, and we're going to talk about a couple different things with assemblies, bringing in your very first component, building things on 0, and how to start constraining your assemblies. And I'm sure some of you have heard about joints versus constraints. They essentially do the same thing. We're going to do a whole separate session just on joints for two reasons. Number one, I'm old school inventor, so I do a lot of constraints, and I need to brush up on joints, and I want to make sure that I do a good job for all of you showing you joints, so I need to kind of work through those myself a little bit first, and because I don't want to confuse you between the two of them. So we'll stick with some of the traditional constraints. They work very similar, so the process is similar. Just typically you need fewer joints versus constraints. So again, joints will be a whole separate one. So if you have questions on joints, we will do a whole separate webinar just for those. So let's jump right in. I'm going to put the resources back up for you. So if you want to check out the Inventor trial, you can check out the projects that go along with that trial. There's our What's New page, the Idea Station forum. So all those links should be listed there that you can check out. And let's jump right in. So the first thing that I want to talk about is I want to talk about work planes. And work planes are something that you have to be able to create when you're running Inventor, because you're going to not always be creating just squares and circles, or you may need to work in a specific location. And when you go to the work plane option, there's a ton of work plane options there, and the challenge with seeing those work planes is there's just a lot of different options there, and which ones do you pick? How do you select the right one? With work planes, there's a much easier way to do this. So rather than having these 2, 5, 7, 8, 11 or 12 different types of work planes, if you just issue the work plane command, and we talked about shortcut keys last week, anytime you hover over anything, you see where it has the right bracket beside the word work plane. That means that you can just issue the work plane command by hitting the right bracket on your keyboard. So you could do it either way. I'm going to do that. And let's say I want to create a simple work plane. I can pick any flat face. So remember, work planes can only be flat. You can't have a curved work plane. So let's say I want to put a work plane on this back face. I can just pick that face. And if I pick and hold, I'm now doing an offset work plane. You can see that distance off of that back face that work plane is being moved. I can key in a specific value, let's say 8 millimeters. And now I have a work plane that is exactly 8 millimeters off of that back face. It shows up in your browser. If you edit the dimension, it will allow you to edit that particular value. So if you wanted that to be 4 millimeters, you can update that to 4 millimeters. So that's a pretty simple one. But the cool thing about work planes is it's a smart command. What I mean by that, when I issue this command again, and let's say I pick this face here, and then I pick this face here, Inventor automatically knows that I want to do a mid-plane work plane. It looks at those two faces, it knows that those two faces are parallel, and it puts a work plane right down the middle of those. We can also do that with this face and this face, so these are not parallel. So I think a lot of people thought it only worked with parallel mid-plane work planes, but it'll split the difference on anything. So if I pick this face here and then I pick this face, which is, they're clearly not parallel, if I pick that, it automatically splits that difference and puts a work plane exactly 60 degrees, because this is probably 120 degrees. Let's do a quick measure on that and check it out. So between here and here, yeah, it's 120 degrees. And between those two, it's 60. So it automatically splits that difference for me. So those two right there, just the offset and the mid plane, or I call it a splitting work plane, are really good work planes to create some pretty quick geometry. Just a reminder, if you have any questions, just ask them in the question panel. I have James on the line helping out with questions. He will, I'm sure, interrupt me at some point in time today and ask a few questions. So again, any questions, ask them in the question panel. So the next one is, let's say I need a work plane that is on this conical surface. This starts to get a little more complicated. Now you need to do multiple steps to create that work plane. It's not just a pick. So I could create a work plane that is parallel to one of these existing planes. So I could do parallel, let's say that plane right there, and I can make it tangent to that face, that curved face. So it will automatically, if I look straight at this, and I'm going to turn my project on ortho faces on, so I'm looking right at it. So it's parallel to that original work plane, tangent to that outside circle. But what if I want that to pass right through that location? I want it to be tangent right at that mid plane. You need to do a step ahead of time. So what I'm going to do is a splitting work plane. So I will split these two. So that's my tangent point. Basically, I want a perpendicular work plane to that right now. So what I'll do is I'm going to create, and there's a couple ways to do this. This is just the way I do it. I'm going to create a sketch on this work plane. I'm going to hit F7 to slice my graphics. And I want just that edge right there. So I'm going to project that geometry. I'm going to grab just that edge. I'm going to finish my sketch, and what I end up with is a plane, or rather a line, right exactly at the tangency that I want. I'll shut the visibility of this plane off. I don't want to see it. When I do a work plane with that line and that surface, if I pick those two things, the line itself and the surface, it makes it perfectly tangent to that specific point. So in some cases, to create work planes, you have to create either a work plane ahead of time, perhaps a sketch. I could have done this with a work axis. We're going to leave work axis and work points to another session because they're usually pretty quick. I just want to make sure that we get into some of the work planes. The other thing that you can do with these work planes is you can do a specific angle between a line and another face. So I will use these two existing ones, and if I pick work plane, if I pick the line and this work plane, by default it goes to 90 degrees. And what I'm going to do now is I can just drag the arrow if I wanted. I can kind of go 15 degrees, 20, all the way around, whatever I want to do. But if I want that to be 45 degrees, I can just type in 45. If I want it to be negative 45 the other way, I can flip it over the other way. And that's how we can create work planes in really specific locations. One second.
Hey, Luke, can I interrupt you here?
Oh, please.
So we have a question about I guess your model tree structure, we'll say. So you have part 3 up there at the top that you're working on.
Yep.
Part 3.ipt. And then I see that you have solid bodies as a 2 or something like that.
Yep.
And so the question is, how do you make under the part those 3 solid bodies or the 2 solid bodies?
Okay, good question.
Yeah. They have parts, but they don't have solid bodies listed under there.
Yeah, so this is a technique called it's called multi-body. So it looks like I'm in an assembly, so I'm just going to shut the visibility of these planes off right now just so I can show this. So if you look here, I have this glass or clear insert. It's this second body. I'll actually change the color of this body to something different, just so it stands out. So this is a modeling technique where you create multiple bodies inside of a single part file. So this is a way of, for lack of a better term, faking an assembly. So I have 2 separate components here. I can shut the visibility off of one. That is this part. I can shut the visibility off of the other, turn this visibility back on. And what this allows you to do is, especially if you're doing concept modeling, this is a really great way to quickly create parts all in one environment without having to go to an assembly and assemble them and put them together. Some people really don't like this technique. I shared a tip on how to do multi-body parts, and some hardcore Inventor users like, oh, that's not the right way to model. And while I do agree with them, it's a really quick way to create concept models. Or if you're making really small assemblies, and you don't necessarily need a bill of material or need a exploded view of a drawing or of a model or something like that. So the way you do this, and I'll just start a new file real quick. This will go super fast. So we'll do a quick file. So, and I'm not going to do any dimensions, so don't yell at me, all you Inventor gurus out there, for not constraining or dimensioning anything. But let's say I have a component. I'm going to extrude it. We'll go that far. And now let's say that I want to create another component, and I want it to be different. So I'll put a sketch on this face. Let's say this is going to be a cylinder. When I go to extrude this, you have this option right here that says New Solid. When I hit New Solid, you see I only have one solid body there. When I hit New Solid and I hit OK, I now have two separate solid bodies in one part file. So this is a really, again, quick way to create a little small kind of fake assembly. I couldn't do a bill of material of this. There is a way to break these out into individual parts, but that's what you want to do. So most all of the creation commands have the ability to create new solid. So if I do another sketch over here, and let's say I want to do maybe some type of revolve of something, and I will do a quick revolve. I'll pick my axis. Let's say I want to do an angle, 90 degrees. If I pick New Solid, again, I'm in a create command, I do New Solid. Now I have three solid bodies that I can work with. So that's how you create those individual solid bodies. Great question. I do that a ton, especially during training classes, because you don't have to leave and do different things to show how you build geometry. So great question. Alrighty, so that is Workplanes, and we got a little extra with solid bodies. Great question. What I want to make sure we get into now is assembly modeling. So is there any other questions, James, before we jump into assembly modeling? If you're paying attention.
Nope, you're good to go for now.
Okay, perfect. Okay, so when you do assemblies, assemblies are basically collections of parts or sub-assemblies. So I'm going to create a new sub-assembly here. I'm going to do an ANSI millimeter. Now, a couple things when you're looking at assemblies, though, you got to keep this in mind, is there are different standards that you follow depending on where you are in the world potentially, or what the drafting standard is that your organization follows. So there are a number of different assembly types. So there's ANSI, there's DIN, there's BSI. So whatever one you need to use for your particular standard. There's also weldments. So weldments allow you to weld your assemblies and create welded material in an assembly. We're just going to do a standard millimeter assembly. We'll talk about the different types of assemblies a little bit later, probably not today, because we do want to talk about welds in another session, but we're just going to do just some standard assembly of components. So an assembly is exactly what it sounds like. So it's where you drop in components and assemble them. So there's nothing in it by default. I'm going to do place component, and inside of my place component, I'm going to grab the different parts that I want to work with. And in this case, I have to save a couple of these, so let me do that first. So there's my side piece that's saved, and these are just some parts I created right before the webinar. That is saved, and let's save that. Okay. So what I'm going to do now is I'm going to place some components. So the first thing I want to do is bring in my base component. So let's do all files. There's my base component. Now, the very first part you bring into an assembly typically is the most important, because this component needs to be on 0, 0, 0. And by default, I'm just going to turn the visibilities planes on. By default, what Inventor does is it drops in that particular assembly. But if you notice, this part is just kind of floating in space. It doesn't lock it into 0, 0 for you. So if you take a peek here, this is just kind of floating up in space. So this part is not locked in. It's not constrained. It has degrees of freedom. So the very first part you bring in typically is the part that you want to lock into 0, 0. So I'm going to do this with constraints. Again, we'll talk about joints at a separate time. So the constraint command has all kinds of options inside of it. We're going to focus primarily just on this first assembly constraints. We're not going to worry about motion or transitional or constraint sets right now. And we're going to be working with flush and mate components. So I'm going to switch over to a flush, and what I'm going to do is I'm just going to pick all of these corresponding. So I'm going to go YZ to YZ, apply, XY, or XZ to XZ, apply, and XY to XY, and apply. So you see that the 0, 0, 0 of this particular part file is now locked into 0, 0. And now when I try moving this part, if I pick and hold, I get this kind of no symbol. That means this part can't be dragged in and out of plane. So it's totally locked in, and that is how you want your assemblies to be. There has to be, at a minimum, one component that is locked in to 0, 0. Some people might come in and ground these components afterwards just to be safe. You could right-click on your component and hit ground. That puts a little thumbtack in the browser. And you don't have to do that, but just in case a constraint got deleted and you don't want your whole assembly kind of falling apart after that, it's not a bad practice to ground it after you have constrained it. Okay, so let's start bringing in some additional components. So we're going to place, we're going to bring in a couple other files here. So let's bring in our side piece. And I need 2 of these, so I'm just going to place 2 of them. And I'm also going to bring in, I don't know where I put my wheel at. There it is. I'll bring in the wheel, and there's going to be 2 of those. And I'm just going to shut the visibility off of these origin planes because they resize based off of the geometry there. So once I have my components kind of laid out where I want to use them, I'm going to go to a perspective view just so it looks a little more realistic, kind of easier to see the depth. And what I want to do now is start putting these together. So again, I'm going to go to my constraints. And anytime you're working with cylindrical components, it's a whole lot easier, especially if you're lining up centers. So a perfect example, and I'll show this 2 different ways. There is a constraint called insert, and it does exactly what you think it does. It will insert this circular face and match it up against that circular face. I'm going to hit OK, and now you'll see that this has a single degree of freedom. That insert basically does 2 constraints at one time. Not only does it line up the centers of those holes, but it also lines up the face of those holes so that that circle, or so that plate is exactly on the side of that. So the next constraint I want to do is obviously that center and that center. So I will issue my constraint. I'll pick this, switch over to insert, and I'll pick that one. And this works because those holes are the exact same distance on both parts. So what would happen if they weren't? I'm going to show you real quickly. So I'm going to go over to my side piece, and I'm going to adjust the hole location. And let's say that this first reference, let's make this, I don't know, 12 millimeters over. So now these centers are not matching, and you'll see this is going to update. So you can see that that one shifted, but now when I try to constrain this one here with an insert, with that one there, it doesn't allow me to constrain that because they physically don't match up. They need to be the exact same size. So when you're doing constraints, if you're doing these types of constraints, you have to make sure that they match up, or you can create your constraints a different way. I'm sure you guys and girls are all experts, and that you know exactly how to create your geometry and that they're perfectly, lined up. So I'm sure that's not an issue. I'm going to undo that change there, and we should be back to where we were. So yeah, so let's hit OK and back to our assembly and update that. And now we should be able to constrain with an insert that face and that face. So that's an easy way to do geometry that lines up perfectly. The next one I want to do is, let's say we want to do this, and we're going to do this a little differently. This one's going to take more constraints, but this shows the different types. So the first constraint we want to do is a mate constraint. And if you look at the mate constraint, if you basically put your hands out in front of you and you think of like putting your palms together, that is a mate constraint where they face one another. A flush constraint is if you took your palm and turned your hand over and put the back side of your hand inside the palm where they face the same direction. So I want this face to basically point, if you look at the arrows, up against that face. So those two faces are now, mating, pointing at one another. I'll hit apply. That keeps me in the command. Now I want to do this face here and this side face, but I don't want that as a mate because I want those to point the same direction. So now whenever I flip that to a flush constraint, those two arrows, if you look, are pointing the same direction. I'll hit apply. And then finally, I'll pick the bottom face and the bottom face with a flush, and they are both pointing the same direction. Apply, I can hit cancel, and now both of these pieces, if I try dragging them, are located perfectly. They're fully constrained. And this is really important to fully constrain your geometry, because if you don't, it creates all kinds of issues as your assemblies get bigger and more complex. Don't forget, if you have any questions, ask them in the question panel. James will either interrupt me or he will answer it himself if he can, and I'm sure he can. So the next one that I want to do is I want to bring in these two wheels, and then we're going to create a component in place, which is a technique that if you're not familiar with creating geometry in an assembly, you got to watch how you do it, because depending on how you do that, you could be making connections, which you may want to do or you may not want to do, but we'll do that in 1 second. So the next one is going to be these two rollers or wheels. So I will constrain, and the mate isn't necessarily, I can pick an axis and an axis. I'm going to hit apply, and an axis and another axis, and hit apply. So now these two wheels line up, but if you look, they actually, it's kind of tough to tell, but they rotate. So now what I could do with these two wheels is I can actually start to constrain these how I want them to be in place, and then I can add the shaft that passes through all of this later on. That's what we're going to do here in a minute. So I'm going to constrain as a flush this face, or as a mate, that face and that face, and let's say I want 2.5 millimeters between the two of them. So this allows you to offset a particular distance from one face to another. I'll hit apply, and then I'm going to mate this face and this face. It actually flips the component over. Those centers are still mated, so those axes are still mated, and that is also going to be 2.5. So that's exactly 2.5 off, and I will hit apply. So now these wheels, all they do is roll, and you may want to keep that degree of freedom available. You could lock it down, and I want to show that moving. So let's put a keyway on this wheel. So let's put a quick sketch here, and I'm just going to put a really quick key in here, and we will do a constraint between that and that. And let's do that, and let's extrude, and let's do a cut distance all. Okay, so now we have a keyway in there. So now we can see when these rotate. And if I wanted these wheels to line up from side to side, I could actually constrain these keyways if I wanted. I could come in here and go to my constraint. I will do a flush from that keyway face to that keyway face. And I didn't like that. Let's try that again. Let's do a flush on that keyway. Yeah, I must be doing something wrong. We'll just skip that. That's okay. Did we have a question here, James?
No, I was just saying that was well done.
Thank you. I appreciate that. Thank you. Yeah, we'll cover that one next week. All righty, so let's do just a quick save. Just a quick tip with Inventor. So Inventor doesn't auto-save for you. It gives you a reminder to save periodically, but I'm sure you've all been there where you're working for 20 minutes, half an hour, in my case sometimes like 3 hours, and something happens, you forget to plug in your laptop and the battery dies, whatever it might be. Make sure you save every now and then. There's a reminder setting to do that. So the next thing we're going to do is we're going to build a component in the context of an assembly, and that's going to probably be the most difficult thing today to kind of grasp. So rather than, like we did, we created this side part all by itself, we created the base by itself, we created the wheels. What we're going to do now is the shaft that passes through all of this, we're going to create that now. So what I want to do is, instead of place component, I want to create component, and it automatically goes to your default file location. So if you're not sure about projects and that sort of stuff, make sure you check out the very first Inventor 101 webinar online. We talked all about project files, so make sure that you check that out. And we will start this with a metric millimeter IPT file. That's the location. And the first thing it asks for is, where do you want to build this component? Like, where's the location? And I'm going to choose the origin plane of the assembly that passes right through the center of all of this. You see that work plane right there? I'm going to pick that. What happens when you create geometry in the context of an assembly is, because you're in a part file, everything else grays out. So what I want to do now is I want to create that shaft component, and this shaft is going to be associative. So what that means is, when this component changes, this shaft is going to automatically update. So the first thing I want to do is grab some geometry that I need to basically constrain to or lock into. And I think I did a sheet metal file, didn't I? Yes, I did. Let's hit undo there. Let's create a component. And let's try that again. Metric, there we go. Standard millimeter IPT. I didn't want that to be a sheet metal part file. Let's try that again. There we go. Okay, now that I have that origin there, what I can do is, the origin of that file is now shared with the assembly. So it's locked into 0, 0. It's right where I want to start. I'm going to do a new sketch on that origin plane. I'll look directly at it. And now what I want to do is, I want to, and there's my save reminder. What I want to do is now start grabbing geometry from the assembly that I want to reuse. So I'm going to project geometry. I'm going to grab that circular face and that circular face. And the first thing you're going to notice is my sketch now has this little recycle symbol. What that means is, this sketch is associative in context of this assembly. So if this assembly gets wider or narrower, the shaft that I'm building is going to automatically update. So what I'm going to do is draw a line from center to center, and I'm just kind of eyeballing this. We'll lock this in a little bit later. We'll look right at.
Hey Luke, while you're doing this, is there a shaft option in assembly mode?
There is. There's actually a design accelerator that allows you to, and we have a whole webinar after this 101 series. We're going to talk about design accelerators. So yes, there is a shaft generator inside of Inventor.
Great, thank you.
Yep, no problem. So the first thing I want to do is I want to make this coincident with that, so it's exactly centered. I will make that and that coincident, so it is exactly the radius of that hole. So when I go to revolve this, and I'm going to dimension from here to here, this is going to be how far out I need this to stick from the side there. So let's just say that's going to be 10 millimeters. Wow, that's big. Let's do 3 millimeters, and we'll do the same thing on this side. So now I'm just going to do a really quick revolve. I just want to get to the point where you can see this automatically update. So we'll do a quick revolve. We will change the material of this part just so you can see it. And I'm going to finish edit. So what you're going to notice is this shaft component has a recycle symbol on it as well. And what that means is it's adaptive. I think I was saying associative before. I meant to say adaptive. So that part is adaptive, meaning it will adapt to what happens in the assembly file. So let's say this base here gets a little narrower. Typically, if you were doing this without Adaptivity on, I would have to go in and change potentially multiple components. In this case, it's just the single shaft. So when I go to my base, I'm actually going to close this, and I'm going to show you this in the context of the assembly. So I'm just going to double click on the base to edit it. And in my browser, I can see my very first extrusion and my sketch, and I can see that this is 80 millimeters, so I'm going to edit my sketch. So remember, I'm in the base component right now, editing that sketch. And let's say this is going to go to, it's 80, let's go down to 60 millimeters. So I will finish sketch. My base updates. Now what do you think is going to happen? If I did this correctly, whenever I finish edit, everything should automatically update. So that is the power of Adaptivity. Now, Adaptivity, again, when I talk to some of the old school Inventor users, Adaptivity is a great thing to use, but you want to make sure you use Adaptivity logically. You don't just want to make absolutely everything in your assembly adaptive, because when those changes start to propagate, it could cause problems, right? So let's say this shaft was a common component that that is that particular size. If I make this adaptive and then I change the length and width of this and it automatically updates, well, what if that shaft is used somewhere else? Because, you know, this is Inventor, right? You're reusing these components. You're hopefully running Vault and making sure that these components are being, you know, reused, and you're creating redundant geometry. Well, if this shaft is adaptive and it's used other places, guess what just happened to where that is being used in other places? It just changed length and potentially caused problems. So Adaptivity, again, is a great tool, but you have to use it really intelligently to make sure that you're not going to create additional problems for yourself. So, so that is Adaptivity. The other way that I could have created this shaft is I could have created this as a completely, you know, independent component. It didn't have to be adaptive. I could have created a 10 millimeter diameter. I could have made it whatever length I want, and then as I made changes, I could go in and update that. So, so that's a really quick look at some of the assembly constraints inside of Inventor. The one thing I want to make sure that we talk about inside of the assembly environment is we talk about patterning. So let's say this was going to be a roller system where there was going to be multiple instances of this little micro subassembly, right? And maybe this is for carrying steel, perhaps. I could come in here and I could pattern. I could come in here and pick all of these parts, and I could do a linear pattern, and I could say that these are going to be 100 millimeters apart, and there's going to be 15 of them, and I could create this. But that's probably not the right way to do this. It works, but what I want to introduce you to is the concept of sub-assemblies. So this is, let's just say, a completed part. We're just going to say that all of our clip rings and nuts and bolts and washers are all holding this thing together. I'm going to save this assembly. And now what I'm going to do is I'm going to create another assembly. So I'm going to do a new standard millimeter assembly. And now I want to place that subassembly. So now the whole thing gets placed as a single component. So if you look in your browser now, I have an assembly, and this is where that intelligent way of building assemblies really comes in handy, because now my bill of materials are going to be more accurate. I'm going to call this out as a subassembly or a purchased subassembly. And now what I can do, again, we always want to make sure we constrain this stuff to 0, 0. It's really important that you do that. So this piece here, it's floating just like it was before. So I want to take all of these planes here, and I want to line those up one with another. And I'm just going to use my constraints again, and I'm just going to do basically 3 flushes. So I'm going to flush that one and that one, apply that one and that one. I'm going to apply it, and finally that one and that one. So now this is locked into the 0, 0 of the assembly as a subassembly. Let's just kill the visibility of those. There we go, and we'll shut the visibility of these ones off too. So now what I want to do is, at this point, I want to do my patterning or my mirroring or my copying or whatever I might be doing. So just like you did at the part level, this command works the exact same way. So what do I want to do a pattern of? I want to pattern that subassembly. It can be rectangular or circle. I'm going to do a rectangular pattern. There is one direction. This is going to be 200 millimeters. I'm going to do a second direction, and this is going to be 100 millimeters. Let's make it 200 by 200 millimeters. And let's say in this direction, I want 10 of these. So let's say this is a roller assembly or a conveyor assembly, and you needed all of these for carrying some super heavy steel or equipment. You hit OK, and now you have a component pattern of those particular rollers, and this is why I like working in perspective view, that really helps you create those assemblies much faster. And when you create that bill of material inside of your drawings, it's going to be way more accurate. It's going to be what a traditional bill of materials is supposed to look like. So the other thing that you can do with the assemblies, and this is just some general visibility type stuff. I'm going to go back to this assembly, and this is the idea of creating different views of your components. So inside of here, you can do all your different visual styles. there is a tool here, and I use this a lot. So if you've ever seen any of the pictures that I create, or some of the folks create in Inventor, that kind of look like this. They have a really cool quarter section in the background, that sort of thing. The way that's created usually is by using this section view tool right here. So what you do is you issue a 3/4 section, you pick the two planes that you want to work with, and you get a really cool looking 3/4 section view. And it didn't actually, slice that geometry. It's just a visual of what that would look like if it was sliced. Some folks do this with an actual extrusion, so they'll actually cut material away as a feature. This is just graphical for viewing purposes. But the cool thing is, when you do this, when you do your ray tracing or your rendering, it actually keeps the slice there. So this is why using this is really powerful. You don't have to do a physical extrusion to get these kind of graphical results. You can just do it with a 3/4 section view, and then you can ray trace it and get those super cool high quality renderings out of your 3D models inside of Inventor. So so that is about it for today. We are going to dig in a little bit more to some additional constraints next week. We're going to start talking about joints next week. We're going to make sure that we cover all the different things inside of assembly. So if there's any questions, we have a minute or two until we get to 45 minutes here, James. Is there any questions that anybody has, or James, if you have any preloaded for me?
We have a couple. One was just, could you scroll through the operation used to make part 3, the one that we were looking at to start the webinar? They were interested in how that was created.
Oh, this one?
It's a very compelling looking part.
Okay. Yeah, so I'm actually just going to use my end of part here. If you've never done this before, if you take your end of part and you drag it, it'll actually walk you through step by step, kind of sequentially, how you built that particular component. So the first thing I did here was obviously just a pretty simple sketch, 35 millimeter with an extrude. I added some work features. I lofted from my bottom sketch to a 23 millimeter circle. So that created that lofted piece. I could have done an extrusion with a taper. There's a couple of different ways. There's always 2 ways to do things, or 20. I punched a hole in it. After I punched the hole, I added a tab here. From there, I revolved from one side to another. I squared up my edge, mirrored over to the other side, because I wanted these to be parallel, and this is why this was a tricky model here. I wanted this face here and this face here to be parallel, but if you look at this, that's a curve right there. So that's why I did this as like a 2-step operation. I revolved it first right there, then I basically cut it away and made those 2 faces parallel. I then added a revolve on the end to get the stops. This is actually a little metal component in a tripod. So if you kind of think the legs go down, those are the little locking nubs. I punched a hole. I started doing some fancy filleting, did a pattern, added a couple of chamfers. I added my multi-body part there, so my second solid. I threw in a few cosmetic threads, and that's it. The rest of that's just Workplanes. But yeah, it was pretty straightforward. Figuring out doing a revolve and then extruding to flatten that up was a little tricky, but not too bad. Next question, James?
There's one more. I'm not sure I understand it, though. It was, why did you use a plan? Or maybe a plane?
Yeah,
this was maybe.
A plane for, or to just say?
I'm not sure. That was all we got. So I asked for a little more info. So if you have more to add to that, let us know. But other than that, the one thing that I was curious about was the threading in those holes. It looks like that's some sort of image overlay, but can you model those in there somehow as well?
Yeah, so the threads in here are cosmetic threads that you add with a thread command, or you can actually do it, in the hole command itself. So if I edit this feature, I can add threads in the hole itself. There is no automatic real thread inside of Inventor. But what you can do is you can do a helical coil. So there is a coil command. So you could draw the thread profile and basically coil it with the pitch that is required to get those real threads. I'm going to give you a warning about that. When you start creating real threaded geometry in your models, it's going to affect performance. I don't care what kind of computer you got. When you think about the complexity of a real threaded helical cut through a component, and then let's say you have lots of those, and then you build an assembly, that's why traditionally I never ever do real threads inside of a model. These threads here will show up inside of your 2D drawings. They will be automatically called out with hole and thread notes. So for all intents and purposes, it does exactly what you need it to do. The only time you would do a real helical cut for a thread is if it was some kind of oddball custom thread and you needed to generate the code for that for some CNC toolpath. But other than that, I'd watch doing helical cuts in real threads, unless you're just doing a cool rendering. Sometimes you do it just for a picture, but for production purposes, I'm gonna kind of caution you against it.
Great. And it looks like that's about it for the questions today.
Okay, perfect. So thanks, everybody. I appreciate you hanging out for another Inventor 101. Don't forget, this is an ongoing series. We got a couple more, maybe 3 more weeks of this until the end of June. It's every Thursday at 2 o'clock. You can send the registration link that you have to anybody on your team. The more the merrier. I just want to make sure that we're getting people trained the right way and getting people using Inventor as much as possible. So I will see everybody next Thursday, 2 o'clock. Have a good week. Bye now.